Hi, everybody. Thanks for coming to my talk. So just a little bit of background. My background is in computer vision. Also, I used to do analog circuit design. I'm not sure if anybody does hardware here. So I come from an engineering background, and I'm a research scientist. And so I just want to talk about some things I've been thinking about for, well, this is mostly work that I've been doing the last year. But anyway, so you know, AI is everywhere, and it's not this kind of AI that I want to talk about. Although so many people talk about this kind of stuff, and that's not really what I'm worried about so much. I'm worried about the really boring stuff, you know, the stuff that's not so glamorous, which is kind of all of these different algorithms that are being used in many different places that I'm still learning about every day. I find out something new. I'm going to start. Sorry, I'm going to have a stopwatch here to make sure that I'm in time. So for example, there are machine learning algorithms that are being used to control our electric systems, our water systems, and my favorite, so, you know, self-driving cars and cars in general that are not self-driving, but this is a good example. Is anyone from HireVue here right now? It's not, okay. I've been contacted by their PR team so many times, but so HireVue is a company that has over 600 customers all around the world, and they what they do is they have, instead of thousands and thousands of recruiters sifting through resumes to figure out who should be invited for an interview, they have automated tools that do this. And so what they say is that the people who use these automated tools found that they have more diverse hires, right? And this could be true, you know, but the thing is we don't know, right? Because we don't know what the characteristics of their automated tools are. We don't know what kind of data was trained on. We don't really have any sort of legal framework or standardization framework to ask these questions and get these answers. But what I found out, like a new information that I found out is also now, in addition to these automated tools, looking at resumes, when you're being interviewed on camera, you now get recorded on the interview. Has anybody gone through an interview? So like you have through HireVue, every single time there's someone in the audience. Can I ask you some questions? They're easy. So did you know that you were going to be recorded on camera? Okay. Did you know that emotion recognition was going to be, your face were going to be analyzed, using emotion recognition software? Did you sign some consent forms and things like this? Did you read the consent forms? So I learned that HireVue uses emotion recognition software. I think it's from Affectiva, because Rana, who's the founder of Affectiva, told me that while we were in a panel together. And so the thing is now, and so what they say is that they give verbal and nonverbal cues to the employer, which is their customer, right? So in addition to your interview, in the things that you're saying to answer the questions, now the employer has additional kind of information about, I don't know what, like, I'm not sure, your facial expressions, your emotions, I'm not sure, right? To enable them to assess whether or not you're the right person for the job. So, so I don't know, again, like, we have not done a systematic analysis of emotion recognition software, right? So when Rana started Affectiva, like she talks about, the first thing she was thinking about was kids with autism, and there's other kinds of people that they work with too. Like some people have talked about how It helps to work with people who have dementia and things like this. But then these systems have systematic errors, and we haven't really analyzed them. And then again, there's no sort of standardization framework that tells us that you have to have certain types of characteristics in your system in order to use them in something as high impact as hiring, right? So imagine now if this system has one type of error, systematic error, it's being used all over the world for all sorts of jobs, for everything, right? And so that single point of error kind of worries me a little bit. So we all know, sometimes the market goes up, down, and up again because of some instability in the algorithms. And I'm sure everybody here has probably read Weapons of Math Destruction and Automating Inequality. These are some of the books I recommend. There's others I haven't read yet, like Meredith Broussard has Artificial Unintelligence, which I haven't read. And then Safia Noble has Algorithms of Oppression. I haven't read these yet, but I've heard good things about them. And so I'll talk a little bit about my journey towards working on this. You guys can sit down. And then if you want to leave in the middle, you don't have to hide, so you can sit down wherever. So the way I approached this was around 2016 when this ProPublica article came out. And before that, I was, I had some sort of activist streak because just by necessity mostly, because of my background and things like this. But I always kind of separated that side of me from the technical side of me because I was also very, very worried about getting credibility as a technical person. I didn't want to be the black woman talking about black women things in computer vision. I wanted to be known first for my work in computer vision and then separate out whatever other stuff I did, And so I was very, very adamant about this. I was very careful about this, and I even had fights with my advisor about this kind of stuff. But around 2016, so there was a few things that were happening at the same time. First is that in my field, or in our field, there are very few black people. So when I go to these international scientific conferences, I remember in Barcelona at NeurIPS, I counted, 5 black people, or 6, actually, black people out of an estimated, I think now the number is 5,500 people from all around the world, right? And at the same time, there's all these conversations about bias and automation and who's going to be affected by this, universal basic income, etc. But the people who are going to be most affected by this were not at the table at all. And so that, I was starting to think about that. It really bothered me, and I was, starting to work on a group called Black in AI, and, that was something I was working on. At the same time, I read this ProPublica article that talked about, I think probably everybody knows about it by now, but it talked about crime recidivism rates and the fact that this company called Northpoint was selling these this product that kind of gives you a probability of someone's likelihood of committing a crime again, and that judges were already using this as one of their inputs to do a bunch of things. One is for sentencing, to figure out, how many years you should go to prison for. One is to figure out bail. How high risk are you? And so at Black in AI this year, one of our keynote speakers was Terrence, who was wrongfully convicted, first of all, wrongfully accused of a crime 2 times, wrongfully convicted the first time, and couldn't get, bail. His bail was set too high. And then the second time, he knew he had to fight it, but the bail was still set kind of pretty high because he was deemed to be high risk from these types of algorithms, right? So this was my very first time hearing that this kind of stuff was happening in the US, that there was actually something out there that was being used commercially in such a high-stakes scenario without being discussed in regulation or law or anything like that. And this, I can't explain to you how much it scared me. It really terrified me because immediately I could think about, I could bring my own experiences with the with my background living here, I could just think immediately about all the ways in which this could go wrong. At the same time, I could think about how the fact that a lot of the people who think about all the ways in which this could go wrong are not represented in this field. And so I could imagine how a lot of people wouldn't think about how all the ways in which this could go wrong. And so that really, really scared me. And last year, I signed a letter against something called the Extreme Vetting Initiative, which was something that was proposed by ICE. They were proposing to partner with tech companies to analyze social network data to figure out certain things like who should be allowed to immigrate, are you more likely to be a good citizen, are you more likely to be a terrorist, et cetera, et cetera. So I kind of want to pause here for a second. I want to say, like, there are two things we should ask here, right? The first one is whether or not we should be doing something like this in the first place, right? Should we, if we had tools that worked perfectly, should we be making predictions about people's likelihood of being something and then making decisions about whether or not to allow them to immigrate, et cetera, et cetera? The second question is, do we have tools right now that are robust enough to be used in this type of high-stakes scenario? So the second question is sort of what I want to address in my talk today. So, like, there is this news story where this Palestinian guy woke up one day and he said good morning in English, in Arabic. He said good morning, and it was translated by Facebook Translate to attack them. And then he got arrested. He was later let go. But there's a few things going on here, right? A couple of things going on. Okay, so the first one is that the good morning got translated to attack them. You know, obviously that's a problem. But you know, the first thing is how well our translation tools work for different languages. I don't think that French to English translation would have this kind of error, right? And so that's the first issue, is the types of systematic errors we have and where those errors prevail. The second thing is there are some groups of people who are targeted at the target of these types of tools, right? Surveillance and other things. There's just usually certain groups of people, because of socioeconomic status, because of politics, etc., who are the targets of these kinds of tools. And a lot of times, these people who are the targets of these tools are actually the people for whom these tools don't work very well for, right? So it's like a double problem. The third thing that's going on is automation bias, right? So people did not think to say, hey, let's check the translation, because the translation might be wrong, because they just trusted the translation. So Ayanna Howard at Georgia Tech does she did a really great, she studies trust in these systems, and she's a roboticist. And she had a great paper where what they did was they simulated a fire, and there was a robot telling the students what to do, like where to go, and it was giving them instructions, and they were trying to see, like, when the students would stop following this robot around. You know what I mean? What does it take for them to, like, not? Oh, is there something wrong? Oops, sorry. Okay, I can take the scarf off. Fine. It's fine. So if you watch the video, it's very interesting. Like, the robot would guide them towards the fire. Like, they have like a simulated smoke, I think, even. And they would still follow it. The robot would guide them towards like these very convoluted paths, etc. So they would still follow it. And so, you know, so the combination of things, the systematic errors, socioeconomic status, automation bias, etc., underrepresentation of people in the specific field, I think, you know, can result in some pretty adverse effects, right, on people's lives. So, because I was talking about analyzing social network data and natural language processing tools, one example I want to give is this paper that probably a lot of people know about by my colleagues some of them are at MSR, some of them are at Google. So by Tolga, who is the first author, and a bunch of other people, and well, James Dow, who's at Stanford, Adam Kalai, who's at Microsoft Research. So they basically analyze word embeddings, and word embeddings are, you can think of them as a space in which things that are, words that are similar in that space. You learn a space, you train it on some sort of corpus. It could be like, in this case, I think it was Google News or something, some sort of text. And so you learn a space in which words that are deemed to be similar according to some sort of mathematical distance metric. These words that are deemed to be similar are closer to each other along some distance than words that are deemed to be dissimilar, right? So then you can use this space to train an analogy detector. And so, I'm sorry, an analogy generator. So for example, like they have, he is to brother, she's to sister, right? And so he's to doctor, she's to nurse. Nurse. He's to doctor, she's to what? It should be doctor, but it generated nurse. And many of us probably would say nurse. Like if you did this word association thing to me, I want to, not be sexist, but like I would say nurse probably. So this shows that you have inadvertently kind of encoded all of these societal biases that we have into this word embedding that you've learned. And then it's, he is to computer programmer as she's to homemaker. That's what it generates, right? So some people might ask, okay, so you have this isolated system, you have this word embedding, it's learned this type of bias. What does that have to do with like things I talked about, like hiring and crime recidivism and whatever? This is like this one like isolated thing, right? And so I want to speculate. I'm going to speculate because I don't know how any of these automated tools work, right? I don't know because there's no like standard, or there's no documentation that needs to be released with any of these tools. So let's say you have two identical resumes, and you're looking for someone who is a computer programmer. So it's conceivable that because there are many things that indicate a computer programmer, and people might not write in their resume, I'm a computer programmer, you might use a word embedding where, like you look for the words that are close to computer programmer, right? So Python, whatever, Java, whatever, can be closer to computer programmer. So that indicates that maybe the resume you're looking at is that of a computer programmer. So you could probably use the word embedding that I talked about earlier to do this kind of analysis, right? But so then here you have experience, etc. The only difference between these two resumes is one person is a quarterback at the University of Vermont, and then the other person is a softball team captain at Spelman. And so Spelman is like an HBCU. It's a historically black college, and it's for women, right? So you're thinking, and then softball, so you're thinking it's probably a black woman. The prior person is probably a white male. So now if you have a system where the white guy is closer to computer programmer than the black woman, then you have inadvertently, again, but without thinking about it, created a system that discriminates in hiring that probably breaks EEOC laws. You could be breaking current laws right now. We don't know, right? So this is why like these little systems that we don't think about can propagate errors, systematic errors that, again, can have huge impacts. Another thing I want to talk about, this is part of my work. Well, this one is not my work, but so at the Center for Privacy, I think it's called Center for Privacy and Security at Georgetown Law, I think they're probably the experts on how face recognition is used by law enforcement, ICE, etc. In this country. And so they had this report called the Perpetual Lineup Report, and they talk about how 1 in 2 American adults is in a law enforcement face recognition network. And law enforcement can just, they can query this database and use it however they want, right? And so once again, there's two questions. Should we have this kind of database? Should they use it in this way? Second one is like, what's the current state of face recognition or automated facial analysis tools? And are these tools robust enough to be used in this kind of way, right? Like, surveillance, like trying to figure out who's a criminal versus not. And so, this is a highly publicized kind of issue where Google Photos identified some black couple as gorillas. Actually, it also identified a lot of white people as whales. But, so it's not like it made a higher error on black people, darker-skinned individuals versus lighter-skinned individuals. It was the type of error that was the problem. It's not as offensive to mistake, to have that type of error, like white person whale, right? But black person gorilla, it's highly offensive because of the social context that we're in, the history under which it's been used, et cetera, right? So it's not always about one error being, one group having higher error rates than the other one. It's also about the type of error. So my own research showed that we analyzed with Joy Bolamini at MIT Media Lab. This was actually a part of her master's thesis, which is like a huge document that you can read. It's much more comprehensive. So we took a piece. We wanted to analyze commercial automated facial analysis tools, and that's because when she was doing an art project, she noticed that a open source computer vision face detection tool would just not detect her face. And she didn't know what was going on. She wouldn't detect her face. She would borrow her roommate's face. It would detect her roommate, not her. And so she then decided to put on a white mask. It would detect her face when she had a white mask, right? And so we tried to so that this is when we wanted to analyze kind of what was going on. Right? So if you were going to analyze an API that you pay for, this is not a research paper that I don't have access to the training data or anything. Some developer pays for this API. What kind of characteristics that do these APIs have? So what we did is we took gender classification systems. So these systems, they look at a face, and they give you a binary label, male, female. No other types of identities. And we wanted to see how well these systems did by different subgroups. And so what we found was that the darker and darker the skin type, it approaches random chance, right? So here, if I flip a coin, it's 50% accuracy. So if you look at, for IBM, for example, you have like 46.8% accuracy. So since this paper has been presented, like all of these companies have now changed their APIs, and like they perform better. But this was what we found, which was a wake-up call. Like, what else is a problem like this? And so initially, when you look at the overall accuracy, when you don't break it down, right, you look at 93%, 90%, 87%. Like, just ship it, right? It's doing just fine. But when you start, well, I'm not going to talk about this much more because I don't want to spend too much time. Oh, well, okay. I guess I already covered it. But what I'm trying to say is, when you don't break it down by gender and skin type, it looks like your system is doing just fine. When you break it down just by gender, you start seeing certain, I thought I had those slides, that's why I was going to, you start seeing like some gap in errors. When you break it down by gender and skin type, that's when you see the highest gap in errors. So this is kind of why for us is related to the intersectionality theory in critical race theory, right? That was created by Kimberly Crenshaw. She talks about when she gives this example of some black women suing General Motors in 1976, I think, and they said there was discrimination in hiring, and they lost the lawsuit because what the judges said is that General Motors hires a lot of black people, and then it also hires a lot of women, so they can't be discriminating against black women. But what they failed to see is that they hire a lot of black people for factory positions, and they don't hire women for factory positions. They hire a lot of women for secretarial positions, but they didn't hire black people for secretarial positions. So if you're a black woman, you were screwed. But because they didn't do this intersectional analysis, they just couldn't, they said, you're okay. So that's why when we're testing our systems, we should also kind of have this kind of thinking when we're doing our testing. So I don't want to talk. So we had to create our own data set, what we call the pilot parliaments benchmark. That was not to do this testing. That was not what we wanted to do. But the thing is, when we looked at existing data sets, they were overwhelmingly lighter skinned and overwhelmingly male. So to even start doing our analysis, we had to create our own data set. So people had been doing face recognition or automated facial analysis tools, research and all this stuff for a long time. But we found that all of the data sets were not very diverse, right? And so a lesson here, for me included, as a researcher, I hate collecting data. When I was doing a PhD, this was the worst part of my PhD. It takes a long time. So you just try to do it as fast as possible. You write papers on how to do it as fast as possible, how to do it as cheaply as possible. It's the bottleneck. So what you do is you scrape the web, get celebrities, etc. So there's a lot of computer vision models trained on celebrities, for example. So what is the bias of celebrities? What's the age? What's the race? What's whatever, right? So we have to think about these things. Oh wow, I kind of want to. How much time do we have? 5 minutes? 5 minutes. I really want to stop for questions. I have so much to say, but I want to really quickly say so. One of the things I want to talk about is standardization. So I have this paper with a whole bunch of people called data sheets for datasets. So that's what I want to talk about really quickly. Data sheets for datasets, it's inspired by electronics in the electronics industry, where you have data sheets associated with each component, like a resistor or something, that talks about non-idealities, right? And we don't have that for any sort of model in AI for any data set in AI. So we have one paper called Data Sheets for Datasets. We have another paper called Model Cards for Model Reporting. But I kind of want to stop here because I want to have time for questions.